Hello world! Greetings from Albuquerque, New Mexico as we start this session of the PASS Virtual Summit 2020. My name is Leslie Andrews, and before we start I would like to take a minute to tell you about all the great things that PASS has to offer you as a member. First, you can become a pro member for an annual fee and get access to exclusive trainings. There are local user groups and SQL Saturdays, which are a great way to network with other professionals in your area and maybe start speaking yourself, free webinars, and getting involved and interacting with people in real life in person someday soon. Be sure to check it out by going to pass.org. And finally, before we get started, both the organizers and I would really appreciate your feedback on this session. There is a link in the navigation bar to the left that will take you to the evaluation page. Please take a minute and let us know. Today's session is Becoming an Azure Certified Data Engineer. This is the first session in the Becoming a Data Engineer learning pathway. The next step in the pathway is either Andy Leonard's Moving Data with Data Factory or Building Data Lakes in Azure with Dustin Vanoy. The final step is presented by James Serra, and it covers Azure Synapse Analytics, a data lakehouse. As I said earlier, my name is Leslie Andrews, and I am currently a senior consultant at 3 Cloud Solutions. I have 20 years of IT experience working in government, software development, and data warehousing. I spoke at 7 SQL Saturdays in 2018 and 11 in 2019 as an Idera Ace. I competed in Speaker Idol at Summit in 2018 and 2019, and now I am here speaking at Summit. And I am a certified data engineer. Today we are going to talk about the types of certifications that Microsoft offers, the requirements for getting the data engineer certification, practice sites and learning paths. We'll review some of the testing topics, and finally how you actually sign up for and take the tests. So you want to be a certified data engineer? Are you sure? In September of 2018, Microsoft changed the way that their certification system was set up, and certifications were changed to role-based. There are currently 9 roles that you can become certified in: developer, administrator, solutions architect, data scientist, AI engineer, DevOps engineer, security engineer, functional consultant, and of course, the data engineer. There are currently 6 fundamental certifications, and these are good for people who are new to the technology or looking to start or change careers. There are some advanced and specialty certifications, like the SAP Workloads and IoT Developer, and the Microsoft Certified Trainer. The functional consultant certifications all focus on the Dynamics 365 set of products and services. There are a series of Microsoft 365 certifications that fall mostly under the administrator role. And the rest are Azure-based certifications: database administrator, data analyst. It could be that some of you would be happy having that certification because you actually work a lot with the data. Or maybe you're interested in AI, and the Azure AI engineer would be a better fit for you. But if you decide that you really want to be a data engineer, here's what the certification says you'll have to know how to do: design and implement the management, monitoring, security, and privacy of data using the full stack of data services. Today we will explore some of the services available in the stack during our discussion. There are 2 data certifications. The Data Fundamentals is awarded by passing DP 900, and if you're new to data architecture or just want to see if this learning path is something that you want to continue to pursue, this is a good introduction to all of the topics required. The Certified Data Engineer is awarded after successfully completing both DP 200 and DP 201. Let's talk a little bit about the tests now and what they cover. The main difference is the implementing versus the designing. In DP 200, someone else has already decided what the solution is, and it is your job in the test to implement those decisions. In DP201, you are asked questions about what the design should be based on a given scenario. It is also good to know the tests do not cover preview features, and I personally found that there was a lot of carryover between the two tests in the topics, materials, and questions. We're going to start off by discussing DP200. It doesn't matter which order you take the tests in, but each test is concentrated into 3 areas. DP200 focuses on implementing a data storage, developing and managing the data processing, and monitoring and optimizing the data solution. When we do a deep dive into each of the concentrations, we see the specific skills that are assessed in the test. DP200 was just updated on September 24th, and I'm working off of the testing requirements as of that update. Implementing the data storage solution requires knowing about non-relational and relational data stores, the data security, data processing, including batch and real-time streaming, and then monitoring tools and optimization techniques. Cosmos DB is the Azure NoSQL, which stands for Not Only SQL, offering for a globally distributed, low-latency, multi-query API database for managing data at large scale. Blob storage is an object storage solution optimized for storing unstructured data. It's designed for images, files, audio, video, storing your log files, backups, using it for disaster recovery and archiving. Data Lake Storage Gen 2 is built on blob storage, and it allows you to have a hierarchical namespace on the storage, and it combines the benefits of blob storage with Data Lake features. The Azure Cosmos DB supports APIs for many standard NoSQL databases, such as MongoDB, Cassandra, and Gremlin. You must know which type of NoSQL database is used in different scenarios. For instance, Gremlin is a graph database and is used for nodes and relationships. Cassandra is a columnar database, and MongoDB is a document database. There's also a table API, which is used to connect to Azure Table Storage. Not only do you have to know which API to use with which Cosmos DB, you have to understand how Cosmos DB is built. It uses containers, which are schema-agnostic containers of items. And depending on the API you use to create the database container, the underlying structure will be specific to that choice. It is important to know which type of container and items are created by which Cosmos DB APIs. The SQL API will create a container with rows. The Cassandra API creates a table with rows. MongoDB creates a collection with documents. The Gremlin API has a graph with nodes or edges. And finally, the Table API also has a container with tables and items. As many of you know, in Azure there are 3 ways to accomplish most tasks: the Azure portal, the command line interface or CLI, and PowerShell. You will be asked to accomplish creating different Azure items using all 3 of those and need to know the syntax for each. And finally, the last topic I will talk a little bit about here is the consistency levels in non-relational databases. You must be able to determine what is the best consistency level based on the scenario provided. Distributed databases that rely on replication for high availability, low latency, or both make trade-offs between the read consistency and the availability, latency, and throughput of the data. There are 5 levels offered by Azure: strong, bounded staleness, session, consistent prefix, and eventual consistency. These levels are well defined, and each level provides availability and performance trade-offs. Let's look into that a little bit more. So the eventual consistency is pretty straightforward. Eventually the data will replicate. So it has a weaker consistency, but higher availability, lower latency, and higher throughput. Strong is the opposite: stronger consistency, lower availability, higher latency, and lower throughput. Session is kind of in the middle. The user doing the reading and writing will always see their changes in the session, but other users have to wait until replication occurs. You will need to understand how each consistency level works so that you can identify them in different scenarios. Other topics in the non-relational data storage solution include providing access to data to meet security needs, requirements and implementation of high availability and disaster recovery, and global distribution. When we move into the implementation of relational data stores, we have Azure SQL Server and Synapse, formerly Azure Data Warehouse. Again, you have to be familiar with all the ways to create the databases via the portal, the CLI, and the PowerShell. You have to understand how billing occurs on both of these options. SQL Server is billed in database transaction units, or DTUs, and you can set it up so that there is a single database that uses all the DTUs, or you can have an elastic pool that lets multiple databases share the resources. Do you need a managed instance or a SQL database? There are some things that are specific to each type, and you must know what those are so that you can choose the correct options. Then we have Synapse, which combines traditional data warehousing with big data analytics. It gives you a way to ingest, prepare, manage, and serve data for business analytics and machine learning. Synapse is billed with DWU, or data warehouse units, and compute costs are calculated separately from the storage costs. So when you create a Synapse instance, you get to select those DWUs. The default is set at 1,000 at a little more than $15 an hour of processing time. We can scale that down to 100 DWUs at about $1.50 an hour, all the way up to 30,000 DWUs at $453 an hour. Now, after you launch your data warehouse, the first thing that you should do is go and pause it, because if you do nothing else, you will be billed. Your data warehouse is running as soon as you create it. And if you are unlucky like me, you will use more than your monthly allotment in a single day just doing nothing. So, pro tip, go out and pause your data warehouse after you have finished creating it, and don't spend a whole lot of money unnecessarily. Another major topic in the implementation of relational data stores is the Synapse architecture. As we can see here, Synapse uses a node-based architecture where connections are made to the control node, the single point of entry to Synapse, and the massively parallel processing engine, MPP, optimizes the query for parallel processing and passes operations to the compute nodes. There is a maximum of 60 available compute nodes, so your data can potentially be spread across all of the nodes. DMS is equal to the data movement service, which is the transport technology that coordinates the data movement between the compute nodes. Understanding this architecture is crucial to understanding the sharding of the data and which distribution options to choose for tables. There are 3 types of distribution, and each of them are good for specific types of tables. A round-robin distribution spreads the data evenly across the nodes and is best for staging tables. A replicated table caches a full copy of the table on each node and is best for small tables like dimensions. And the hash distribution, where a hash function is used to assign a row to a node and is best for fact tables. You have to consider the selection of the distribution column to optimize the table and select the correct distribution and partitioning. Now let's talk a little bit about Polybase. It's a tool that's included with Synapse that allows you to query data from files stored in blob storage or Azure Data Lake. You have to know the steps required to configure a Polybase connection, and there are a couple, and you have to know what order they have to happen in. So here are those steps. First, you have to create the master key on the database. You have to create database scoped credential for the blob storage where your files are stored. You have to create the external data source, which is the file. You have to create the external file format, which is the structure of the file. And then you create the external table. And what that does is it creates a section right here in the external tables where you can see those files, but they look like tables, and you can query them just like tables. And there are different types of files that you can set up for it to use, but the fastest way to load is using the Parquet file structure. Another major topic is security. Azure Active Directory is Microsoft's cloud-based identity and access management service, which allows people to sign in and access resources like the Azure portal, Office 365, Microsoft Teams, and thousands of other software-as-a-service applications. You can use it to access on-prem and internal applications, and also authorization and authentication to your internal intranet and network. One of the applications you can connect to with Azure Active Directory is a SQL Server, either Managed Instance, Azure SQL Server, or Azure Synapse. You may get questions about built-in database roles where you have to identify which role should be given to employees so that they can perform specific database tasks. For instance, if you were asked about picking which database role would allow a user assigned to it the ability to manage permissions, and you had to choose between DB Access Admin or DB Security Admin. Which one is the correct one? In case you're wondering, it's the DB Security Admin role that allows you to manage permissions. Maybe you need to use an application role. An application role is a database principal that lets an application run with its own user-like permissions. There's also role-based access control, which helps you manage who has access to Azure resources, what they can do with those resources, and what areas they have access to. There are some built-in database roles that allow very granular and segregated abilities. For instance, SQLDB Contributor lets you manage SQL databases but not access them, and you can't manage their security-related policies or their parent SQL servers. SQL Managed Instance Contributor lets you manage SQL Managed Instances and the required network configuration, but you can't give access to other people for that managed instance. SQL Security Manager lets you manage security-related policies of the SQL Server and the databases, but you don't have access to them. The SQL Server Contributor lets you manage SQL Server databases and servers, but not access them and not their security-related policies. There are also built-in roles for the Cosmos DB. You can also use Azure Key Vault, a cloud service that safeguards encryption keys and secrets like certificates, connection strings, and passwords. This comes into play for data when developers need their applications to connect to databases. Instead of storing the connection string in the app's code, you can store it in the Key Vault. You can set up monitoring and logging of access to the Key Vault, and it integrates with Azure Disk Encryption and the always encrypted and transparent data encryption functionality required in SQL Server and Azure SQL Database. And again, we have to have an understanding of high availability and disaster recovery for our databases. We can use georeplication and availability zones. Active georeplication is an Azure SQL database feature that allows you to create a readable secondary database of individual databases on a server in a same or different data center, aka region. Active georeplication, however, is not supported by Azure SQL Managed Instance. For a geographic failover of instances on SQL Managed Instance, you have to use auto failover groups. Knowing the different ways to back up and restore databases, failover servers, and failover groups are just a few of the topics covered in this section. And the final concentration in the implementation section of the test is managed data security. First, dynamic data masking. The purpose of dynamic data masking is to limit exposure of sensitive data, preventing users who should not have access to the data from viewing it. You can create custom masking rules, and there are several built-in masking patterns: default, email, and random. You have to know which data masking technique to use in specific situations. You also have to be able to identify, based on query results, what the masking rule is or what data will be returned for a specific rule. And finally, encryption. Encryption at rest and encryption in motion. You should know the types of data encryption, what always encrypted means, and how to protect data. Encryption at rest, that means that the data is encrypted on the disk, which protects the data if a nefarious person were able to get the physical disk that the data is stored on. Without the encryption key, it is extremely difficult to extract the data from the disk. Encryption in motion refers to the ability to encrypt the data that is being transferred. This is done with the transparent data encryption and encrypts the data in real time. The always encrypted feature allows you to encrypt data within client applications prior to storing it in Azure SQL database. You have to be able to identify which encryption method is correct for the scenario presented to you. This wraps up the first section of the first test. Moving on to the second section of Test 1, we're going to move into the developing and managing of data processing in both batch and streaming of real time. When we talk about batch processing solutions, we're talking about using things like Data Factory and Databricks, Polybase ingestion, the integration runtime for Data Factory, using linked services, datasets, creating pipelines and activities, scheduling and creating triggers, using Azure Databricks to create clusters and notebooks, and using jobs and auto-scaling, being able to ingest into the Databricks. For the streaming solutions, you have to be able to configure the input and the output, use the windowing functions, and be able to do event processing with stream analytics. When we look at a standard processing pattern using these cloud technologies and services, we're going to start with our business and custom apps collecting transactional data, or our sensors and devices collecting IoT data. And then we're going to ingest that using Data Factory or a Kafka pattern, or using Event Hub or IoT Hub. If we're going to use one of the hubs, we have to understand that IoT Hub allows for bidirectional communication back to the device. So if you have to have applications that write back to your sensors to do firmware updates or any type of interactive communication with the device, then you know that you have to use IoT Hub. There are some IoT protocols that are only supported by IoT hubs. You have to know which service to pick for which situation as it is described in the question. When we're using the Windows functions, tumbling, hopping, sliding, or session, you have to know which ones do which things, which ones repeat, which ones overlap, which ones have events that can belong to more than one window. These are functions that are used in the group by clause. And one little trick that I used is that the session Windows function, the one with no ing, is the only one that also filters out no data. So that's a little tip to help you remember which is which. We're also going to use some of the other services that we've talked about. We're going to use the blob storage or data lakes to store our files. We're going to use Databricks to prep and train. We're going to produce some machine learning algorithms that allow us to do some analytics. We're going to model and serve the data in either non-relational or relational databases. In a Synapse, we're going to have analysis services that push out to our intelligence, visualization tools, predictive apps, and analytic dashboards. Now I'm going to run through a quick demo on setting up a Databricks cluster. To begin, we're going to sign into the Azure portal at portal.azure.com. Once you get logged into the portal, we're going to select the plus to create a new resource. You can search for Databricks or go to the Analytics link, find it in the list, and select it. The new Databricks service page opens. You'll select or create a new resource and enter in the workspace name for your Databricks service. Select the location and the pricing tier. I'm going to use the premium 14-day trial. We'll review and create. Once it has been validated, we'll push the create button and it will deploy our Databricks service. Once the deployment is complete, we can select the Go to Resource button, which will allow us to launch a Databricks workspace. Databricks uses Azure Active Directory for authentication, and once you are signed in and the Databricks workspace opens, the first thing you have to do is create a cluster. Nothing can happen in Databricks without one. To open the New Cluster dialog, you can select the New Cluster on the launch page, or select the cluster icon in the tray, which opens the Cluster Manager page, and then select Create Cluster. After entering a cluster name, select the cluster mode. High concurrency is optimized for concurrent workloads in SQL, Python, and R, but does not support Scala. Standard mode, which is recommended for single-user clusters, supports all the languages. We're going to stick with standard mode. There is no pool, which is an additional research that allows the cluster to start quickly. And we're going to select our Databricks runtime version. This lists all of the currently supported versions and the beta versions available. There are also 2 machine learning variants available, the standard machine learning and graphical processing unit machine learning. I'm going to select the newest non-beta version. The autopilot options include the Enable Autoscaling, which toggles between a variable or static number of workers. The Auto Terminate time box shuts the cluster down after the specified time period has elapsed with no jobs running. Here's where we're going to select the types of workers for our cluster. You can either provide a fixed number of workers or a minimum and maximum, depending on if you enabled auto-scaling. If you provide a fixed-sized cluster, Azure Databricks will always use that many workers. If you provide a range for the number of workers, Databricks picks the appropriate number of workers required for the job. The system does some real-time validation of processing capabilities, and this warning is letting me know this account doesn't have enough CPUs for the level of workers selected. If I lower the max number of workers, the warning disappears. Next, we pick what kind of workers to use. The bigger and beefier, the faster, and more expensive. There are several different types of workers. We're going to select a lightweight general purpose worker with a DBU, Databricks unit, of 0.75, which is the unit of processing capability per hour, and prices range from 7 cents per DBU to 55 cents. We're going to use the same driver type as the worker, but we could, if we wanted to, have a beefier driver. The driver node runs the main functions and executes the parallel operations on the worker nodes. Once we've filled out all of our information, we select the Create Cluster button, and now we have a Databricks workspace with a running cluster that we can use to start in our own Databricks notebook development. The final topic in DP200 is monitor and optimize data storage, data processing, and data solutions. The monitor portion is almost all done through the Azure portal. You should familiarize yourself with how to implement monitoring on all the storage and database products we have talked about: Blob Storage, Data Lake, Synapse Analytics, Cosmos DB. You have to know how to monitor relational and non-relational data sources, configure alerts, and implement auditing. So when we're looking at some of the things that you have to do for the monitor and optimization, you have to implement monitoring system-wide. You have to configure monitoring alerts, auditing. You can set up auditing for particular groups or particular items. You can see when personal identifier information has been changed or modified. You can set up very sophisticated rules for your auditing. You have to troubleshoot data partitioning when we talked about the sharding and the distribution of the non-relational data stores. If those queries are running slowly, you may need to go in and optimize the data partitioning, figuring out which fields to do the partitioning by in the distribution of your non-relational data stores, and then system optimization, just basic, are your queries running quickly? Do you have enough data? Do you have enough storage? And that wraps up DP200. We're going to move on now to DP201. So now we're going to move on to DP201, designing an Azure data solution. So like the previous test, this test is broken down into three main topics of questions. And again, we have data storage solutions, design data processing solutions, and design for data security and compliance. When we look deeper, we're going to look and see that we need to recommend Azure data storage solutions based on requirements, design relational and non-relational, real-time processing. Wait a minute. This looks almost exactly like the deep dive slide from the DP200 session, except it says design everything, not implement everything. And that's because it is. Like I said earlier, there is a lot of overlap between the two tests in what you have to know and the things that you have to be able to do on the test. DP201 is a lot of the same materials, a lot of the same questions, just from a slightly different angle. Recommend data storage solutions based on technical and business requirements. Again, understanding of partitioning and distribution types. All of the same things that we had to know for the implementation, we have to know how to design those aspects of the system we are building. The same goes for the non-relational data stores. We have to know almost the exact same things for designing them. APIs, consistency levels, high availability and disaster recovery. Which ones are the right one to use at any given time, and why would you choose one option over another? On the relational data stores, when would you use a SQL Server over a SQL managed instance? Polybase, where are you going to store the files with the data? Security, who is going to have access to the data, and how are we going to design it to be sure it's protected? High availability and disaster recovery. How are we going to architect a system to guarantee the data is available when it is needed and recoverable if disaster strikes? We have to design the data processing solutions, batch and streaming or real-time. Which piece of the data stack do you use to perform each step in the processing solution? Are we going to use IoT Hub or Event Hub? Are we going to collect data from IoT devices or from applications? We're going to use Azure Data Factory to move the data. We're going to use Databricks to create clusters and allow collaboration between the data engineers, the data scientists, and the data analysts. And then we're going to use Power BI to allow the visualization and the interactive tools that we use for analysis. And from a high level, what is the architecture of the solution to get the analytics to them? And finally, data security and compliance. Who has access to the source data? You want to limit it so only the people who need access have access. Azure is set up so that security can be very granular. What kind of data policies do you need if you're required under HIPAA, GDPR, or other regulatory or security requirements? Those can be created and built into your data system to ensure compliance. You've all heard the joke. How do you get to Carnegie Hall? Practice, practice, practice. Well, the same can be said for passing Microsoft certification tests. Here are some free and paid sites that you can use to help you prepare. The Microsoft Learning Paths are a great way to get an introduction and overview of the technologies and the stack required for the tests. They are broken down into sections for each test topic. Then there are readings and exercises that put those ideas into real-life scenarios. There are paid and free practice sites. For both exams, I used MeasureUp to practice. You can get short-term access, you can get a downloadable version, you can extend it once it has expired. You have two options when you practice, just like the certification with a timer, or practice where you can enable options like show the answer when I'm wrong, otherwise continue when moving to the next question. I also liked that there were explanations for each of the answers and links to the Microsoft documentation that help you learn the way it is. It offers some reporting of your scores over time and breaks your responses down into each testing topic so you can focus your studying. And just an FYI, I just closed this test. I didn't fail that test, so I didn't complete it in time. Other paid sites are MindHub and Exam Labs, and it could be that they have similar options and work the same way, but I don't have any experience with them, but I wanted to put it out there for you to know. Exam Topics, however, is another site that I used, and it's free. It's a little annoying that the site continually asks you if you're a robot, but it is another way to confirm your understanding of the topics. Because here's the thing, there are a limited number of questions in the test bank, and eventually you will just know the answer because you've seen it so many times if you're like me and you take the test over and over again. So I would go out to Exam Topics and test myself to see if I was actually learning stuff or just memorizing the test answers that were on Measure Up. So once you feel that you're ready, which you may never, neither of the times I took the test did I feel prepared. There was always more to learn and know because there is so much that the test could cover. And it would be just my luck to get a ton of questions about PowerShell. There's a system check you are prompted to do before the test on the computer that you will be using. You should definitely do the system check and be prepared before the day of the exam. Before logging in for the test, you have to clear your testing area. You have to be in a room with a closed door, nothing within arm's reach. Log in 15 minutes prior to your exam time, just in case there are issues. You have to take photos with your phone of the testing area and upload them. Once all that has been completed, the proctor will log you on, ask any questions about your testing area, make you move or clear things off that they think are too close, and once they're satisfied, you start the test. You get 180 minutes to complete the questions. There's about 45 of them, and just do it. Do it. See how close you are. Take the test. If you think that you need to, there are options where you get a free retake. Some of the testing options you can buy include the practice test. When you get to taking the test, there are about 5 different types of questions that are asked. There are case studies where you're presented with a scenario and then given different options and asked, will this meet the criteria provided above? There are yes/no questions. There are fill-in-the-blank questions where you're dragging and dropping answers or doing a drop down from a combo box. There's multiple choice questions, and there's ordered tasks. What are the things that you have to do to accomplish this task that's been outlined? Some of them you can do in any order, and some of them it will say do in order. Make sure that if you're on an ordered task that you see is, do I have to put it in order that it happens, or can I just pick the ones that have to be done? Now we're going to do a little study session from the examtopics.com website. I've gone out and gotten a couple of the questions that are freely available on their site on the internet. We'll go through, we'll talk a little bit about some study techniques, testing techniques, how to narrow your options down, and just get a feel for how the test works. Question number 1 is a straight up multiple choice question. You're provided with a scenario. The data engineering team needs to configure a synchronization of data between an on-premises Microsoft SQL Server database to an Azure SQL database. Ad hoc and reporting queries are being overutilized on the on-prem production instance, and the synchronization process must perform an initial data synchronization and perform bidirectional data synchronization after the initial. You need to implement this synchronization solution. What should you use? So if we review our options, transactional replication is useful in the following scenarios. Publish changes made in one or more tables, keep several distributed database in synchronized state, migrate databases from one SQL Server instance to or Azure SQL Server by continuously publishing the changes. Okay. The Data Migration Assistant helps you upgrade a modern data platform by detecting compatibility issues that can impact database functionality in your new version of SQL Server or Azure SQL Database. DMA recommends performance and reliability improvements for your target environment and allows you to move your schema, date, and uncontained objects from your source server to your target server. Well, maybe, but that doesn't really say a whole lot about synchronization. Backup and restore. I guess that could be a valid option, but I don't think that offers the bidirectional sync after the initial sync. SQL Server agent jobs. You have to know those are not available on SQL Database. And the Azure SQL Data Sync. Well, that's promising. We have sync in the word. Is a service built on Azure SQL Database that lets you synchronize the data you select bidirectionally across multiple databases, both on-prem and in the cloud. So basically, by a process of elimination, we're going to see that E is our correct answer. And when we go through and we look at the answer, we were correct. Some of the times when you are reading the tidbits below, you will find things that are the one piece of data that you need to know to answer that question. Can't publish from Azure SQL Database, single database, or pooled database. Transactional replication, that's one of the reasons that this is not a good option. And data sync. So even if you got the answer wrong, we still have some information here that allows us to learn, and again, using testing techniques to process of elimination, come up with the correct answer. And again, here's the reference provided for going out and reading about why this is the correct answer. Question 2. You're the data engineer for your company. An application uses a NoSQL database to store data. The data uses key value and wide column. Developers need to access the data using an API. Which APIs should you use? Which 2 APIs? Again, when you're reading the questions, make sure you read them twice. Make sure you know exactly what they're asking you to find, that you have plenty of time. There is no rush to get through this to click, click, click. Make sure that you are deliberate and thoughtful and reading and answering. Which 2 APIs should you use? So we know we need a key value and a wide column. Well, the first choice is the table API. We know that the table API allows you to access data in the Azure table. The MongoDB is a document database. Gremlin is the graph database. SQL API is the default document database in Cosmos DB. And Cassandra is the wide column store. Right, so now we know that Cassandra, wide column store, is probably one of our options because that's one of the things that we're talking about. So when we look at the answer, yes, we got the Cassandra API, but it also said the MongoDB. And if we look, we can see that there's quite a bit of discussion on this question. That's because the answer below says B, Azure Cosmos DB is the globally distributed multi-model data. Well, except answer B isn't Cosmos DB. Answer B is MongoDB. Well, that's kind of weird, right? MongoDB is a document database, not a key value. So the discussion here is whether the correct answer is the SQL API. Is the correct answer D and E? Because the SQL API is the default key value API used for Cosmos DB. So if we go out to the reference and we look, we can figure out for ourselves what the correct answer is. And that was one of the things that I found most helpful about the references, and the ones where the answer provided may have actually been incorrect, because I had to go out and figure out, well, why did they say that? Why is it wrong? what are these people talking about? And if you go in and you read the discussions, you'll get some insights into other people's thought processes on how they decided what the correct answer was. For the record, I think this is wrong. The correct answer is D and E. Here is a multiple choice for different scenarios. This is to perform batch processing of multiple sets of geospatial data, and you need to implement the solutions. Again, this is a question from DP200, topic 2. I'm not quite sure how they break their topics down, but it allows you to see the categories that we talked about before. Again, not as graphical as it is in the Measure Up because this is the freed site. But if we want to find a native client application to run interactive queries and batch processes, use a web browser to run interactive queries and batch processes, or develop batch processes that use Azure HD Insight. Insight is for Hadoop. If we come through and we look, we can get some information. I don't know about most of you. I didn't have much experience with Hadoop before I got my certification. So for me, having to identify those gaps in the information that I knew to go out and study, so I at least had a basic understanding of those topics that were lacking in my previous exposure because of the jobs that I didn't use them in or whatever reason. Hadoop was one of those things that I had to learn a lot about. I had to learn what tools to use. I had to learn what things you use for what. Again, the documentation that the references that they provide at the bottom are great documentation for learning about those things. The Insight tools for Visual Studio Code is for developing Hive Interactive Query, Hive Batch Job, and PySpark jobs. Hive View is the Apache Ambari Hive View. Allows you to author, optimize, and run queries from your browser. And the REST API are used to create and manage HD Insight resources using Azure Resource Manager. Here is an example of a case study. It tells you you will not be able to return to it. As a result, these questions will not appear in the review screen. These are one chance only. So you need to make sure before you select submit that you have picked the right one based on what you know. This particular one says you are designing a HD Insight Hadoop cluster that uses Azure Lake Gen 1 storage. Now, first of all, I'm going to tell you most of the questions that you're going to see on the current tests are not going to reference Gen 1. Almost everything is done in Gen 2. In fact, earlier on the slide when we were picking our Synapse storage solution, Gen 1 was not even an option to pick. Can't even get that anymore. But for this question, it says the solution requires POSIX permissions and enables diagnostic logging for auditing. And you need to recommend the solutions that optimize the storage. Your solution ensure that the files stored are larger than 250 megabytes. Then you are presented with a second question. Same scenario, implement compaction jobs to combine small files into larger files. Does this solution meet the goal? And lastly, ensure that the files stored are smaller than 250. Do you see why you're not allowed to go and review and change your answers? Because maybe you get to this one and go, oh man, I messed that first one up, because you've remembered something. Because when we look at our solution, it tells us some of the things that we need to know. Avoiding small file sizes can have multiple benefits. Ensure that the files are larger than 250 megabytes. So yes, this solution meets the goals. When we look at our second one, combine small files into larger files, yes, that also meets the goal. When we look at our third one, ensure that the files stored are smaller than 250, avoiding small file sizes. So no, this solution does not meet the goal. And you will get quite a few of these types of questions where you're presented with this case scenario where you have to decide between multiple options and you can't go back and change your answers. Question number 5. A project requires analytics and visualization of a large data set. The following requirements: notebook scheduling, cluster automation, and Power BI visualization. You need to recommend the appropriate Azure service. So again, we've moved into DP 201, which we can tell by our question up here at the top. You are being asked for a recommendation on the service, on designing something. The flavor of the question is just a little bit different, right? So now we have to know what all of these services do. Azure Batch creates and manages a pool of compute nodes, virtual machines, installs applications, schedules jobs. There's no cluster or job scheduler. Well, okay. It says we have to have cluster automation. Process of elimination, probably not A. B, Azure Stream Analytics. If we look that up, it is a real-time analytics and complex event processing engine that is designed to analyze and process high volumes of fast streaming data from multiple sources simultaneously. It consists of an input, a query, and an output. It ingests data from Azure Event Hubs, IoT, blob storage. Again, not really remembering anything about clusters when we talk about stream analytics. Azure Machine Learning Studio, a web portal for data scientists to develop in Azure Machine Learning. It combines no-code and code-first experiences for an inclusive data science platform. Again, I didn't hear anything in there about cluster automation. Azure Databricks, Apache Spark-based analytics platform optimized for Azure. It comprises the complete open source Apache Spark cluster technology. Oh wow, clusters. All right, maybe that's our option. And then our last choice, Azure HD Insight. Well, we just talked about that a few minutes ago. That's all about Hadoop. So the only one of these options that even mentioned clusters was Azure Databricks. So by using the power of elimination, by knowing what things are and the keywords that are associated with those things, is a huge advantage in being able to identify or at least eliminate some other options so that instead of having a choice of 1 out of 5, you've got a 50-50 choice. You've identified 2 things that it might be. And that process of elimination comes in handy when you're presented with questions about distributions. If it's talking about a fact table, you want a hash distribution. If it is talking about a replicated table, then those are dimensions. So you have to know which words go together. So if we look at round robin, those are staging tables. So based on what the question is asking you and the words that it's using, use the power of elimination to get rid of choices that you know are wrong until you are left with the 2 best options if you don't know, and then you have a 50% chance of guessing the right one rather than a 20% chance of guessing the right one. So today we have covered the types of certifications that you can get, the requirements for the data engineer, practice sites that you can use, testing topics, taking the tests, practicing, and now you just have to go study and get certified. Here are some resources that you can use to study and take the test. The testing sites are at the top. You can go to those sites and get the learning pathways, links to instructor-led trainings. Here are the links for the practice question sites, both the 2 that I used, Measure Up and Exam Topics, And then the other two paid ones that I did not, Mind Hub and Exam Labs. And then there are some courses that you can use, some YouTube videos you can go and watch, other presentations like this that were given at other conferences to practice and study with. I'm so glad that you joined me today. I appreciate you taking the time. If you have any questions, we have a 15-minute session coming up following this for a live Q&A. You can also reach out to me at leslie@lace.technology. I'm also landrews5807 on Twitter and LinkedIn. I look forward to talking with you more. I hope you enjoy the rest of Summit. Thank you.